Hello everyone, I hope you all are doing very well. And in this session, we are going to cover basics of search algorithms, basically why search algorithms are important and the basic need of search algorithms in AI, what are key terminologies and important properties, right? So let's begin. Basically, search algorithms in AI are methods which is used to traverse and explore problem spaces to find a solution. So the problem spaces are nothing but set of all states where we can travel throughout in a journey to solve any problem, right? We are going to explore it in our terminology part as well. These algorithms are crucial in many artificial intelligence applications like pathfinding algorithm, like puzzle solving algorithms, like scheduling algorithms, and many more, right? The goal is to systematically explore different states or configurations of a problem until a solution is found. So let's say if we want to find a solution of any problem. So the systematic states, the systematic way, right, the systematic way to traverse each and every state so that at the last we found our goal, right? So this particular systematic way to configure the different state in a journey to explore the solution is called as search algorithm, and it is an important problem, it is an important kind of concept. Basically you can say that in AI search techniques are universal problem solving methods, universal problem solving methods, right? Keyword: universal problem solving method, which is utilized by rational agents or problem solving agent to find solution to a specific problem and achieve their goal. So basically if we want to solve any particular problem, then with the help of rational agents or problem solving agent, we can use any search technique, and using search technique at the end we can found the solution, right? So in AI, search techniques are configured as a universal problem solving agent, means that any problem can be given to us, and using AI they try to implement search techniques into it. These agents typically operates within problem-solving framework where they aim to reach a desired state or achieve a specific objective. Search techniques play a crucial role in problem-solving capabilities of AI agents, enabling them to navigate through the complex problem spaces and find effective solution. Means multiple solution can be there, but they have to navigate through the all spaces and then find out which is the effective one, right? In a wide range of problems. Okay, let's come to the terminologies first, because this terminology will be used in each and every search algorithm that we will further explore. So the first and key most important one is the state. What is state? So a configuration or a situation within a problem space that the search algorithm can reach or explore is called as a state. So let's say initial state. It is a state from where we are starting. Thereafter goal state. It means that we want to reach out that particular state, and meanwhile we may have some more states that is called as search space. That is all the possible set of states where we need to go in order to reach to the goal state. So basically state is nothing but a configuration or a situation within a problem spaces, right? So initial state is a state from where we are need to start, goal state where we need to reach, and search space is set of all possible states that can be reached from initial state by applying action or operations, right? Thereafter we are having search space. Search space is all the meanwhile set possible states that can be possible from initial to goal, right? Search tree. So what is search tree? A tree like data structure which represents the exploration of states and their relationship during the search process. So let's say if I want to implement search algorithm on the state, so there what I need to do, I just need to implement my search algorithm there, and using search algorithm, we need to find out the solution, right? So search tree is just like a data structure which represents the exploration of states. Thereafter, we are having search graphs. a graph like data structure it is, which represents the exploration of states and their connections, especially when dealing with problems where states can be revisited or have multiple paths. So it is a graph like data structure which represents the exploration of a state, then in which manner we have explored. And search tree is just like representing the exploration of a state, that with the help of this initial node we go there, thereafter we visited this, then this, and then at the goal state, right? So trees and graphs are data structures which basically used for searching techniques in order to find the solution. Thereafter, we are having node, a data structure that represent a state. So basically, each state can be represented with the help of a node, just like a concept of node in a tree or in a graph, right? In search tree or search graph, it contain information such as state itself or its parent node, or possibly other attributes like path, cost, like that. So let's say it is one node, one more node, one more node, one more node. So these nodes are nothing but they are representing the states. So this is initial state, it is a node. You can call it as a parent node, or all the space state nodes which will come into the path, they are also a node. Each node contains some data, right? Okay, thereafter age. So basically you can represent age as nothing but the connection between different nodes, right? So connection between nodes in a search tree can be represented with the help of a edge. So initial node, thereafter some space node, so they are connected. So the connection is with the help of edge. Edge is nothing but the connection between different nodes. Thereafter, action or operator, a function or operation that can be applied to a state which leads to the generation of new state. So basically action, when we are at a particular state, we do apply action or operation, and with the help of that action or operation we reach to some new state. So the operations that we are applying and on a particular state in order to go to the next state or to generation of new states, that is action, right? Thereafter, transition model, it is a description of how actions or operators change the state of the problem. So how actions or operations that we are applying, how they are going to change the state of a problem, that is called as the transition model, which basically specify the possible transition between the states. So let's say we are at state A and we have applied a set of actions here. So this is going to change, this is going to change the state of problem now, and they will generate some new nodes. So basically this is transition model, that how we are changing the state of problem, and it specify possible transition of the states. Thereafter, path, a sequence of states and actions. So path is nothing but a systematically sequence of states or actions that will need to reach from initial state to final state. So let's say path is nothing but sequence of states. Let's say sequence 0. So after that we will be here, we will be here, we will be here, we will be here, and it would be our final goal. Let's say you want to make a tea. So initial state is get a milk, add some tea leaves, add some masalas, add some sugar, and then your tea would be ready, right? So the thing is that sequence of states, right? Or actions. So actions are like that, right? Okay. Solution path, a path from initial state to goal state. So whatever path we are having from initial state to goal state, it is a solution path that represents valid solutions to the problem, right? Cost function, a function that assigns a cost to each action or transition between states. Basically, it influences the search algorithm's behavior, especially in the algorithms like uniform cost search or A star search. So cost function is that we are going to assign cost to each edge after performing some action over that, because each action might require some cost, depends on what kind of algorithm we are using. So if we are using uniform cost or A star, where we need to perform such cost functions. Heuristic functions, basically it is a function which is definitely used in informed search algorithms like A star search, and basically it estimates our cost or distance from a state to the goal state. So what is actual cost that might be in the form of estimation, that let's say we are having at a particular at a particular age, at a particular state, and here it is our goal state. So meanwhile, any particular state and goal state, we need to estimate what is the cost to reach from here to here. That can be called as a estimation of a cost. Means just estimating a cost to reach from any particular state to goal state. Basically, it will help to guide the search toward more promising area of search space, and that will lead to generate the optimal solution. Thereafter, frontier or open set, the set of nodes that are candidates for expansion or exploration by search algorithm. So frontier or open set means if you are at a particular node and after applying some actions or operations, some further sets of nodes are opened there that are nothing but the candidates for further expansion of the solution, right? So let's say at this node, these are possible solution, these are possible solution, these are possible solutions. So they are nothing but set of nodes that are candidate for further more expansion, right? That is frontier or open source set. And closed set is, let's say you come here, but before coming here, you have just choose some nodes so that are closed now, means which we have already been explored or expanded in order to search any particular goal. So we have already come up at a particular position, right? But by coming up here, we have already explored some nodes, that is closed set. And depth is distance from initial state to a particular state. Let's say we are having some initial state and we are having some particular state. So just distance from initial state to particular state, that is distance from initial state to particular state in search tree, if I want to find, that is called as a depth. Then completeness. Completeness, so we are just coming to the properties now. Completeness is nothing but if any algorithm gives us guaranteed solution, if there exists one, means if a problem have one solution, then algorithm, if it guarantees that it will give you the solution, if there at least exists one solution, right? So a search algorithm is considered as a complete if it guarantees to find a solution when one exists. Means let's say if a problem is there and there might be solution 1, solution 2 and multiple solutions, then if any such kind of problem is there which should have at least one solution, then any algorithm that we will apply on this problem, if it is guarantee us that yes, definitely it will give you at least one solution, that is called as completeness of problem. Means if there is a solution, definitely it will guaranteedly give you the solution, that is completeness. Thereafter, what is optimality? Optimality is if a problem is having solution 1, solution 3 and solution n, then out of this solutions, that problem will definitely give you the best possible solution, right? So if it will give you, let's say S2, solution 2 is the best possible solution, that is called as optimality property. Time complexity is amount of computational time that is going to be required to compute, to compute, to compute that problem. So let's say if we are solving a problem, then if what is the computational time required to solve any particular problem is a time complexity. Space complexity is amount of memory or storage that is required to execute that problem. And then admissibility. Admissibility in a search algorithm use heuristic information that never overestimate the true cost to reach the goal state. So let's say if there is a particular state, initial state, and there is a particular state, let's say goal state. So admissibility property said that by using heuristic information, let's say there is some actual cost, and whatever cost, let's say we have estimated, let's say estimated cost. So this estimated cost will never overestimate the actual cost. That property is called as admissibility, right? So admissible heuristic ensures that search algorithm will always find an optimal solution if one exists. The next property is consistency or monotonicity. So basically, the thing here is consistent search algorithm ensures that the estimated cost of reaching a goal state from a particular state as provided by the heuristic function is always less than or equal to the cost of reaching any successor state. So it is saying that using heuristic function, if we want to reach from on a particular state, from a particular state to the goal state, then it should always less or equal to the cost of reaching any successor state plus the estimated cost from the that particular successor to the goal. Means you have started from this node, so you are coming to this node, right? So let's say there is a cost 1 and there is a particular goal node. So here you are having some estimated cost. So it is saying that this cost 1 plus estimated cost will be the cost to reach at the goal node. Right. Thing is that why we are discussing this theoretical concept, because when we are going to actual on the search algorithm, this key terminology will be used: consistency, admissibility, heuristic function, right? So we are using it, so we are learning in detail with the theoretical points, so that next time when we will solve the problem, at that point I will talk, this is consistency, this is time optimality, this is time complexity, this is search complexity, so you should aware of it, right? Time optimality, it is find solution in shortest possible time, that is time optimality. Especially optimality means uses least amount of memory that can be possible. Informedness means informed search algorithm use heuristic information to guide the search toward promising areas of search space. Higher level of informedness typically lead to more efficient search and faster convergence to a solution. So informedness is a property used by heuristic functions, or you can say that use heuristic information to guide the search toward promising areas of search space, right? Toward the further areas that we need to go to the solution. So toward promising area of search space, it is going to guide us. What? Informedness. And robustness. Robust search algorithms like resilient to variations in problem instances, search space characteristics, and input conditions. So robust algorithm maintain their effectiveness across different scenarios without significantly degradation in performance. So let's say if some inputs got changed, or let's say some conditions got changed. So in that area, there should not be degradation in performance of that algorithm. That is robustness of algorithm. Means some input conditions or space characteristics can be changed, then it should not degrade, or it should not just change the performance. That is the robustness, right? So based on problem solving approaches and availability of information, two important characteristics I am again telling. What are two important characteristics? The approach that we are using, problem solving approach, and availability of information. So based on these two criteria about problem domain, search algorithm can be broadly classified into two categories. One category is uninformed search or blind search, uninformed search. And the second category is informed search or heuristic search, right? So there are two categories of search: uninformed search or informed search. Uninformed search, which is blind search. Informed search is a heuristic search, right? So what is the base of this? In problem solving approach and availability of information. On the basis of that, search algorithm in AI is classified into two broad area: uninformed and informed, right? So what is uninformed search? Uninformed search is also called as blind search. So uninformed search algorithm explores the search space without any additional knowledge. Without any additional knowledge, if we are reaching toward the goal state from initial state without any additional knowledge, that is uninformed search, right? So they operate solely based on structure of the problem and do not utilize heuristic or domain specific information, right? So uninformed search algorithms are suitable for problems where little or no information is available. So we are at this state, we will just figure out what are the next state possible. Then whatever would be the optimal, again we will choose the next possible state, and in this way we will go. So basically we do not have any information about the goal state, but we are just exploring the upcoming states, and on the basis of that we are going towards the solution node or solution state, right? So that is called as uninformed search, that is blind search. In blind way we are going. So examples are like BFS, breadth first search, DFS, depth first search, uniform cost search, UCS, or DLS, depth limited search, or iterative deepening depth first search. These all are examples of uninformed search. On the other hand, we are having informed search. Informed search are called as heuristic search. So heuristic is a kind of function. Basically, informed search algorithms are also known as heuristic search algorithms, incorporate domain specific knowledge or heuristic to guide the search process toward the most promising area of search space. Means from initial state, if we are going toward the goal state, then every time heuristic will help you that what is the best possible solution that can be possible, what is the best possible promising area. So toward most promising area of space search is nothing but all the steps that will become in the meanwhile process, right? So using heuristic function every time give us the estimated cost, and whatever would be the best possible estimated cost which we are going to obey, right? So that is nothing but helping in exploring the next state with the help of some information. So we are having some kind of predefined information here to reach toward goal nodes. That kind of algorithm is called as heuristic search algorithms or informed search algorithms. The examples are like A star search algorithms, greedy best search algorithms, iterative deepening or A star, IDA star, we can say it like that, recursive best first search algorithm, hill climbing, or simulated annealing algorithm. These all are algorithms of heuristic search, that is called as informed search algorithms, right? So as of now, we have just discussed the basic part of search algorithms. So basic definition of search algorithms. Thereafter, key terminologies, because these terminologies will be helpful when we are going to learn these search algorithms in the next lectures. Thereafter, these properties, that what is completeness, what is optimality. Every time whenever we will see the algorithm, we are going to discuss these properties, that whether this is a completeness problem or not, whether this algorithm is optimal or not, and time complexity of that, space complexity, what is the admissibility, right? So all these are the important properties that we have explored. Thereafter, on the basis of approach and availability of information, search algorithms classified into two areas, that is uninformed and informed. So I hope in this part we have discussed the basic introduction towards search algorithms. In our next lecture onward, we are going to explore the algorithms one by one, right? So I hope each and everything is clear. Please, you can connect with us on these platforms. All these links are mentioned in the description section as well. And guys, do like, ask your comments or queries in our comment box. Feel free to put your queries or comments or suggestions. Have a nice day, guys. Jai Hind, Jai Bharat.